Let's take a look at control flow starting with conditional branching. Conditional branching is a programming technique that lets a script evaluate a condition and then choose which block of code to run based on that result. So when we're talking about blocks of code, we're just talking about a piece of code that belongs to a particular structure or statement. So once we get to the examples, I'll give you guys some more clarity on what that means. So condition is checked, and the result of this check is either true or false. So you can have all sorts of conditions, right? Does the file name contain the word test? Is the number of students greater than 100? Is the test score at least 65? Any of these conditions can be represented in code. And I'll kind of show you how you guys can do that through the next few slides. But essentially, those conditions can either be true or false. If it's true, it's going to follow one path. If it's false, it's going to follow another path. It'll do one block of code or the other, right, depending on this condition. So this means that your single code base is capable of adapting to various scenarios. If you just throw a couple of these if-else statements, which we're going to explore, these conditional statements, if you put a few of them together, if you nest them, you can actually explode the number of paths, scenarios that your particular code will be able to execute. So just with a few of these, you can really make your code adapt to so many different scenarios. Now, of course, right, this is all theoretical at this point. We want to know, how do we actually do this in code? So that's going to be in this next section, conditional branching statements. We'll start with the most simple conditional branching statement, and that's the if statement. If this is true, do this. If not, well, nothing else will happen. So the if statement tests a condition and executes a block of code if it's true. So a block of code is just any code that belongs to one of these conditional statements or looping statements, all the statements we learn. Whatever code's inside that statement is a block of code. So for example, here we see the echo command, right? That's part of this if statement's block of code. Let's take a look at how this is structured right through the syntax. So we have if, we use our square brackets, and inside the square brackets we put our condition, and then after the square brackets it's very important that you put your semicolon, and then after the semicolon we use the then keyword. So if this is true, then do that. If the file name contains the word production or test or development, right, whatever you want, then you're going to do these following commands. Now, if you notice at the end of that if statement, we have an fi. That's just the if reversed, and that marks the end of that statement. And you'll notice this little indentation here. So this is kind of a convention across many programming languages, and some it's actually required. There isn't actually a tab button that you can run, especially if you're in your nano editor. If you want to indent your block of code, which again you should probably do, because that's what programmers do. It just kind of visually you can see where the code belongs, like, oh, this code is indented, so it must belong to this if statement. The way you do that on your keyboard is you're just going to do the spacebar 5 times. Hit that spacebar 5 times, it'll be 5 spaces. That's essentially going to work as your indentation for your block of code. So remember, a block of code is just a piece of code that belongs to one of these statements. So the echo command here, this line, is the block of code that belongs to this if statement. Now, of course, we're going to see longer blocks of code. They're not just one line all the time, right? They could be much longer. But for this example, we just have one line in our block of code. So yeah, the condition checks if the variable has a text value equal to Linux. So for example, this could be a test that a student took, right, on the terminal, or maybe we're reading from a file. We'll learn how to do that. And if the answer they put is equal to Linux, then we're going to output this back to them. We're going to say correct. The best OS is Linux. Now, of course, we usually don't have just a single situation, right? Like if this is true, do that. we usually want to have more conditions, right? More branches to our tree. So this is where the if-else statement comes in. So very, very similar to our if statement. We're going to have the same syntax: if, condition, then, and then our block of code. Now, if this condition isn't true, we want to have a backup, right? A default option, and that's going to be the else. So if this condition fails, you're going to have this kind of catch-all condition that's going to say, hey, whenever the top doesn't work, you're going to execute these other commands. And again, because we're doing code blocks, right, we indent it to show that, hey, this belongs to the else and this belongs to the if. So here on our example on the right, we're expanding it, right, making our program a little bit more robust, more dynamic. So here we say, if the answer is Linux, we're still going to say correct. The best OS is Linux. In any other situation, so in any other answer that's not equal to Linux, the else is going to catch it. It's going to say incorrect. And we can actually reference the variable, right, in our output. So we're saying whatever answer you put is not the best OS, because we're assuming, right, that that answer wasn't equal to Linux. So that's exactly how it works. It's going to execute it from top to bottom. It's going to say, hey, is answer equal to Linux? If this is true, then you're going to do this. Now, if this is false, it's going to skip this line of code, this block of code, I should say. It's going to go to the else and say, hey, else, okay, because everything on top didn't work out, else means it's going to get triggered. It's going to do this code block right here, which is the echo incorrect, right? Answer is not the best OS. So yeah, else is just the default. If everything above doesn't work out, this is the one that will execute. And now we're having our branches, right, go into two different paths. If it's this, do that. And you can have a giant block of code in here. You can have multiple programs, right? One program in the if, one program in the else. And that's how you make your code dynamic, right? We're actually making it make decisions. And of course, we'll look at some examples, some more examples, so you can see how this works. Now, what if you want even more situations, right? A branch on a tree isn't just two sides. It can be 3, 4, 5, 6, 7, etc. To the nth, number, as far as you can think of, right? If you want to combine additional conditions, there is a command for this, or a statement for this. And that's the elif. Elif is short for else if. So it's kind of adding a condition to the if. And then instead of writing a bunch of ifs on their own, which you certainly could do, but a better way, right, to organize it is to chain them together using the elif. So the first elif to be true would be the only one executed. And that includes the if, right? So if the if is true, that's the only one that's going to execute. And then it's going to go down to all the ones you chain together. And until it gets to one that's true, then I'll execute that one and leave the entire branching conditions. Now, if none of those are true, right, and you have an else at the bottom, then that's the one that's going to be the catch-all. To say, oh, if everything else fails, well, you got to do this. So yeah, it allows you to test multiple conditions in sequence. So let's take a look at how this is structured, the syntax of this. So we have two conditions, really three. So let's go with the example of the operating system, right? So let's say if their answer was Linux, then you're going to say, yeah, correct, Linux is the best operating system. Now, maybe I'm a Mac fan, right? Mac OS. So I can have a second condition where if their answer is Mac OS, then you'd print out, correct, this is the second best operating system. And then in the else, right, you could just catch all the other operating systems, Microsoft, Chrome OS, whatever the case may be. And there you say incorrect. Those aren't the best operating systems. It's Linux and Mac OS. So just like that, we're now adding even more dynamism, right, flexibility to our program. We're writing a single statement, because this is a statement chained together, that's capable of making many, many decisions. And again, if you put enough of these in your program, boom, you're now, exploding the number of situations that your program can handle. And remember, right, if for these statements, it's not going to execute two blocks. It's going to wait until it gets to the first block that's true. And then that's the only one that executes. So if the if is true, all the other ones get skipped. If the condition 2 is true, then it's going to skip the else. Now, if none of them are true, right, and you have an else, well, the else is going to be the only one that executes. So just remember that. Only one will be executed at the end. So if you do want to compare, two things against each other, we have the examples of variable A versus variable B. Remember, that could be, an answer that a user punched into your program. It could be a environment variable such as their username. It could be pretty much anything that you need to compare, right, for your particular program. So if you want to see if two numbers are equal, whole numbers, we call those integers, you're going to use the dash EQ. Notice the spaces, right? So it's your variable space dash EQ space, and then your next variable. Or it could be a literal value. It can be an actual value that you're putting in there, like, equal to 5. Is user age equal to 5? Now, if you want to do not equal, that's going to be dash NE. If you want to do less than, that's dash LT. If you want to do less than or equal, which is, is it less than, but also is it equal? It's going to catch both situations combined. You could do the LE. And then we have greater than, GT, greater than or equal, of course, GE. Now, comparing numbers is useful, but arguably, right, comparing strings is even more useful, or just as useful. I don't know. I feel like I do strings more often. If you want to compare strings to see if they're equal, you just use equal sign. That's it. Now, I believe one of my previous examples had a double equal sign, which is not incorrect, right? Answer equal to Linux. There's some slight differences between doing an equal and a double equal sign. None that we need to worry about for our class, so feel free to use one or the other. For the most part, in other programming languages, they do the double equal sign, which is why I like to use the double equal sign. Technically, there are some benefits to the single equal sign in terms of portability. But again, nothing you have to worry about as a beginning Linux user. So let's go ahead and move on. You can use single equal sign or double, up to you. So if not equal, we're actually going to use the exclamation point here. Typically in logical operations, the exclamation point means not, or like the opposite, right? So opposite of equal is not equal. And so then we use exclamation point in the front. If you want to check if the string is empty, you could do dash Z. If you want to see if the string is not empty, you could do the dash N in front. If it's true, right, that means the string is not empty. If this yields false, that means the string is empty. That means there's nothing in there. Let's take a look at an example where we chain together a bunch of conditions. So here we have a program that's going to give our users a very useful output here. It's going to tell them, based on the weather, you should wear this. So we have a few different situations. Of course, in a really complex program, the way that it assigns that weather variable, could be very, very advanced. For us, we're just going to assume, we're not going to worry too much, right, of how that worked. We're just going to assume that it got the right weather. All right, so if weather is sunny, then, so if literally the variable weather is a match for the word sunny, then we're going to do an echo. We're going to output, it's a sunny day, you should wear sunglasses. If it's rainy, if weather is equal to rainy, then it's going to say it's rainy, take an umbrella. If the weather is equal to snowy, then it's going to output it's snowy, you should wear warm clothes. And then in a situation where all of these are not true, the catch-all is the else, it's going to output weather condition unknown, be prepared for anything. So how would this look like, right, based on different inputs? Let's say weather is equal to snowy. So the bash interpreter is going to go here and say, okay, the script says if weather is sunny, but weather is actually snowy. Remember, that's the one we're using for this first example. Is snow equal to sunny? Nope. You're going to skip this code block. I know it's a code block because it got indented. They did the right thing here. All right, it's going to move on to the next condition. Is snowy equal to rainy? Nope. It's going to skip this one. All right, next condition, is snow equal to snowy? Yes, that is true. So then I'm going to execute the code block that belongs to this particular branch. It's going to say echo, it's snowy, wear warm clothes. Wear warm clothes, excuse me. Now, once it executes this, remember, it's not going to continue looking for another path of execution. It's done. These are all together working to just execute one code block. And in this case, the correct code block was the third one because snowy is equal to snowy. That means the else here is not going to get triggered. It's not going to check it. It doesn't need to. Let's go with two more. Let's go with sunny. So sunny equal to sunny, true. It's a sunny day, wear sunglasses, boom, we're done. It got it right in the very first part of this conditional branching statement. So right on the if, we got the money right. We skipped the rest. Because of, the ordering and how it matters, a lot of people will put the situations they think are most common at the top. And this helps your program be more efficient because if you know which things are more likely, then it's not going to go through all the work of checking some of the other branches. So if it's sunny, 70% of the time, put sunny at the top. If it's snowy more often, you should put snowy at the top so that it doesn't waste time, right, checking other conditions. You don't have to worry about this, right? We're just beginners, but just a little bit of insight, right, and how programmers actually design these conditional branching statements. All right, let's say that the weather was, I don't know, gloomy. So gloomy equal to sunny, nope, skip. Gloomy equal to rainy, nope, skip. Gloomy equal to snowy, nope, skip. There's no other conditions, there's just the else. So this catches gloomy and says, okay, because all of these failed, we're going to say weather condition unknown, be prepared for anything. And yeah, that's exactly how an if, elif, else would work.